Welcome to all. In the previous video of differential geometry, we are looking into the examples on finding velocity and speed of the curve. Now we will see an example on arc length of a curve. So how to find the arc length when the two limits of the curve are given or when only one limit is given. We will see the example. The question is like, for the curve alpha of t equal to 2t t square t cube by 3, find the arc length function s is equal to s of t, which is based at t equal to 0, and determine the arc length of alpha from -1 t is equal to -1 to t is equal to 1. So what they asked is, for the curve alpha of t given by 2t t square t cube by 3, we have to find the arc length function which is based at t is equal to 0. First case is we have to find the arc length of the curve which is based at t is equal to 0, and further we have to find arc length of the same curve between the limits -1 to 1. So we will see how to find that. So first we will consider alpha of t is equal to 2t t square t cube by 3. So there is no range for t is mentioned, therefore alpha is a curve from R to E3. Now we know that the formula for arc length function is given by s of t is equal to a to t norm of alpha dash of u into tu. So we can observe a is a scalar which is belong to set of real numbers. So if we mention lower limit as a constant which is from set of real numbers, then this arc length function s is said to be based at a. So it is said to be based at a. So if both the limits are available, then we can write the arc length function s of t as a to b, where a and b are both real numbers, means both are having values. So they are the constants, norm of alpha dash of t into dt. So we can observe in the case of equation 1, so the variable is in terms of u, because the upper limit is variable which is in terms of t, therefore to differentiate between the upper limit and the variable we have taken alpha dash of u and du. So as both the limits are given, then there is no need to worry about the variables, therefore it is in terms of alpha dash of t and dt. Now we will see one by one. So before that we have to find norm of alpha dash of t, means speed function of the curve. So first we have to consider the curve alpha of t is equal to 2t t square t cube by 3. Now alpha dash will be differentiating each component with respect to t. This is 2t, this is t square. Now norm of alpha dash is under root of 2 square plus 2t whole square plus t square whole square. So this is nothing but t is power 4 plus 4t square plus 4. So this is equal to t square plus 2 whole square. So therefore norm of alpha dash of t is equal to t square plus 2. Now we know what is the speed function. By using the speed function for two different cases, when the arc length function is based at t is equal to 0, and for the second case we have to find the arc length of the curve between the two given limits -1 to 1. So now taking first case, so arc length function based at t is equal to 0, therefore s of t is given by 0 to t norm of alpha dash of u into du. So just I am taking u instead of t in case of equations of 3 which gives the speed function of the curve. So this is equal to 0 to t u square plus 2 du. So integrating we will get u cube by 3 plus 2u. Now putting the limits 0 to t, this is t cube by 3 plus 2t. So this is the arc length of the curve alpha of t which is based at t is equal to 0. Now for the second case, so arc length of the function, arc length of the curve, arc length of alpha of t between the limits t is equal to minus 1 to t is equal to 1. In this case s of t is given by minus 1 to 1 norm of alpha dash of t into dt. So just substituting the alpha dash value is equal to minus 1 to 1 t square plus 2 dt. So just integrating and substituting limits, this is t cube by 3 plus 2t minus 1 to 1. So just putting t is equal to minus 1, we will get minus 1 by 3 plus 2 into minus 1 minus of 1 by 3. So first one is upper limit is plus, so therefore we have to put, this is t is equal to 1 by 3 plus 2t 2 into 1 minus of t is equal to minus 1 means minus 1 by 3, t is equal to minus 1 is minus 2. This is equal to 1 by 3 plus 2 minus of minus 1 by 3 is plus 1 by 3, this is plus 2. This is equal to 2 by 3 plus 4. This will be 14 by 3. Therefore, the arc length of the curve alpha between the limits minus 1 to 1 is 14 by 3 units. So this is how we can find the arc length function which is based at some particular base value or between the two limits. This is all about finding arc length. We will see with a different example which is on unit speed reparameterization in the upcoming videos. Till then, keep watching. Thank you.